Next up, we're going to have Barnabas join us. He's going to share a little bit on sequencer design for multi-rollup ZeFi applications. The stage is yours, my friend.
Okay, hi everyone. So I'm going to talk a little bit about sequencer designs for multi-rollup ZeFi applications. The reason we need a sequencer coordinating in a ZeFi application, if it's multi-rollup, is to deliver the proofs quickly and efficiently. The only other way it could work potentially more efficiently is if you have very small proofs and you do client-side proving. That can be very efficient in the future, but right now I think having a sequencer in place ensures that a lot of problems are mitigated, potentially solved. So I'm going to talk a little bit about the interop challenges that exist in the Ethereum ecosystem, like both on layer 1 and layer 2. The first and most obvious one is there is a lack of single slot finality on Ethereum mainnet. When you deposit, execute a transaction, that transaction takes a long time to be finalized. Hard finality is defined as 2 epoch, which is actually quite slow. But even if you take a look at the data, even in optimal cases, we can see that there are multiple reorgs happening on Ethereum mainnet constantly, and you need to mitigate those if you are working with zero-knowledge proofs in a multi-rollup design. The problem is that you can generate correct proofs on a state that is later dropped from the chain, and then you are looking at double spend problems. When we are looking at the rollup space, actually we can observe, and I will show the data in a sec. There are not many reorgs happening. Main reason is the sequencer is centralized, right? So if the sequencer is centralized and it operates correctly, there is no reason for reorgs to happen. And we also need to have like a different view between optimistic rollups and ZK rollups. So optimistic rollups do maintain the capability to reorg. A ZK rollup design has a harder finality guarantees because they don't have the built-in challenge period, and for that reason, transactions have a quicker finalization. And then you have different designs with optimistic and optimistic as well. So if you're thinking about like the two major tech stacks, it's Arbitrum and Optimism, and they both have different methods for finalization, challenge game, fraud game, which you all need to take into account to determine what type of execution are you including in a sequencer design. The L1 inclusion is also non-standard. What I mean here is that both Arbitrum and Optimism tech stacks, they only post the data when the batch is full. So that completely depends on the amount of transactions that are coming in the chain. Right now it's base posting very, very quickly in like 54 seconds transactions to L1, which is very good because it has a harder finality guarantee, and you can be more sure that those transactions will not be dropped. But if the volume is low, then it is going to take longer, and this uncertainty is also quite hard to add into the design because you don't want to have an application that sometimes have a 1 minute latency, sometimes they have like 10-minute latency. That's not super great UX. And then we also need to consider that if you are executing transactions without hard finality guarantees of Ethereum mainnet, so if you want to have a multi-rollup application that has a faster latency than 12 minutes, then you open up an attack vector for forcing reorgs. So you can actually force reorgs on Ethereum mainnet as well. And then we could also see last year in November, the paper was published about a potential attack vector on Arbitrum, which also relied on slowing finalization, essentially forcing reorgs into the chain and using transactions, using the preferred transactions to actually create a double spend attack. Arbitrum since released Vault, which in my opinion mainly solves this problem, but we do need to take into account that there can be such attacks in the future with a similar methodology. And then what I want to add is I think while we were building this design, our biggest challenge was quality of documentation and depth of documentation, especially around like consensus, transaction, finality understanding, reorgs. Most optimistic rollups, they don't really have a programmatic way of reorging. It's not yet programmatic. It's on a case-by-case basis, but this is not well documented. So if we have people here from those teams, I would encourage expanding the documentation. And I do want to add like a very good example is on Optimism stack. They improved the documentation by a huge amount on all of these vectors since last year in May. They have been adding a lot of components, which makes it much easier to engineer a solution. So as I said, there is multiple data on reorgs right now. So Etherscan is adding this data publicly, which is very, very helpful. And we can see that Optimism hasn't been reorged for a year. They had multiple reorgs in the beginning of the chain. On Arbitrum, we can also see it similarly, but they haven't reorged for 1,000 days. And then we can see like on mainnet reorgs are constant. So they're usually like 10, 20 reorgs even during a day, but the reorg depth is usually 1. So you actually have a couple of tools that you can use in a sequencer architecture. You can use light clients, so Helios, Helios OpenStack are very good tools to get the sequencer commitments or the beacon chain commitments, and you can use that to generate a zero-knowledge proof. There will be also a Helios linear implementation that we were doing, so super proud of the team about that. But obviously, like there are a lot of drawbacks. So, like client, it is not doing what a full node is doing. So you have softer finality guarantees actually there. When you include full nodes, and full nodes are doing the block execution. So that's very important because at least you can be sure that the block is correct. And that is, in a sense, very helpful because one of the major reasons why a sequencer would decide to reorg the L2 chain before posting it to layer 1 is because the blocks had a double spend problem. So you do want to make sure that, and in the future with real-time proving, you can start proving all of these things for the different rollups, which are very helpful. And then obviously you want to use like a ZKVM to generate a zero-knowledge proof. And you can program into the proof reorg protections, and that's very important. You essentially want to take a look at the underlying chains that are implemented and determine on a case-by-case basis what type of reorg protection you want in that. And you also want to include other components. So our idea for having a low latency multi-rollup setup right now is to have a slow lane, which is very slow. You need to wait until the transaction finalizes on mainnet. So that's 12.4 minutes plus generating the proof, which is probably going to be another like 1 to 3 minutes for the light client proof on the beacon chain. But it's very suitable for withdrawals. So if you want to leave the protocol, you can still do it in 12.4 minutes, which is much quicker than what you have, for example, on an optimistic rollup. But you do, of course, want to enable users to quickly exit the protocol. And then you want to have like a fast lane, which is more centralized. It's whitelisted. So for us, it's only our team is going to be running this sequencer, and then you can create dynamic confirmation rules based on transfer value. Right? For $100 deposit, when the volume is multiple times of that, you probably don't want to force a long waiting time for the user, and you can do this with quite securely. And we also have built-in 10+ layer to block confirmation just because the proof is taking like 12 to 20 to 30 seconds. And based on the block time, we can calculate this. And the full nodes are providing a backstop because they are constantly running. So even after the proof has been, or even when during the proof is being generated, you have an additional backstop if the sequencer reorgs the block and the block is dropped. That is very helpful for security reasons. So yeah, that's it. If anyone has any questions, happy to answer those.